Okay, welcome to Knowledge Share channel. And today in this video, as a series, we are discussing about the Six Sigma concepts. And in this video, we will be discussing about a case study in Six Sigma. See, for example, there are many case studies. So I have taken a case study like reducing the software bug density in the DevOps pipelines through the Six Sigma approach. So actually, this particular case study has been used by Microsoft earlier, and so it's a very important concept how Six Sigma has overcome the bug density in DevOps pipeline by reducing those software bugs. So, really very happy to share you the knowledge with you all regarding the case study. Also, this particular things has been discussed in our classroom as a case study, and our students also will demonstrate based on the case studies things. So now let's move on with our students discussion, and then come back again. Welcome to Knowledge Share channel. In this video, we will be discussing about Lean Sigma concept. So to introduce myself, I am Dr. C. Uday Shankar. I am working as professor in Artificial Intelligence and Data Science Department. I'm really very happy to share the knowledge related with Six Sigma concepts. So the main competitor for the Six Sigma is Lean Sigma. Earlier, Lean Sigma was the one which was found, and then Six Sigma take its all. But actually, the Lean Sigma and Six Sigma are quite different. And in this video, we will be discussing about the Lean Sigma based concept. And can you just introduce yourself before going into the today's discussion?
Yes, I'm Jenny Insulin, second year MBA from SNS College of Technology, in the specialization of finance and marketing.
Okay.
And myself Divya from SNS College of Technology in second year MBA under the specialization of marketing and finance.
Coming to myself is Varadarajan. I'm an MBA student. I am here in SNS College of Technology, and my specialization is financial and business analytics.
Yeah. So really very happy to have this discussion related with the Lean Sigma concepts. And to start with, can you just tell me how this arrived actually, this Lean Sigma concept actually, when it started actually, and who found it actually?
Actually, it was founded by Toyota in Japan. In the year 1940, initially they were started manually, and after 1990, they have made it technically and improved a lot.
Yeah, so really very important. So this was the seed for Lean. Actually, it was started in 1940 itself. Then after the invention of computers, maybe in 1990s, they invented many tools in order to overcome the many base-based things, and because of which this particular Lean-based Sigma concept has been widely used in many of the industries. And yes, can you tell me the philosophy behind?
As Lean Sigma, the main philosophy is they mainly focus on adding
Value to the customer?
adding value.
Please, no problem.
So first
இல்லை இல்லை பரவாயில்ல எடுத்துருங்க நான் கட் பண்ணிக்கிறேன்
adding that is not value to the customer is waste. Is the main philosophy they focus on Lean Sigma.
Oh, nice. So you have given the philosophy related with Lean Sigma, and now can you just tell me what are the tools that are used for this particular?
Yes, sir. Coming to Lean Sigma, there is many tools available nowadays, but there is one tool which is one or two tools are available in last, which is in oldest tool, which is one is Kanban and another one is 5S. These tools are two.
Can you tell me what is the use of this Kanban, and how far they are different in that actually? Yeah.
Yes, between these two, what is the difference means Kanban is a tool which is used to manage a workflow, and coming to 5S, it helps to organize a workspace in our organization.
So nice. Okay. So we have understood what are the different tools and what is the history behind this particular concept and everything. And can you tell me what are the different types of waste actually this particular Lean Sigma concept is focusing on? Can you tell me? Yes.
Actually, there are 8 types of waste, sir. It's called downtime.
It's called as the abbreviation
Abbreviation is called downtime.
downtime. So there are totally 8 types of waste which are in the industries which has to be completely eliminated, and in short it is called as the downtime. And can you tell me the expansion, or what is the expansion of that particular abbreviation downtime?
As downtime, as a brief expansion, is support for D for defect, and O for overproduction, and W for waiting time, and N for non-utilizing potential, and T for transport, I for inventory, and M for motion, and E for extra processing activities.
Nice. So really very good expansion she has given. So downtime, so it's a very important expansion. So if we really have the focus on this downtime, we will be able to achieve the process very easily. Okay. So yes, can you please tell me what does this downtime actually means about?
So downtime, it's 8 elements they have, and coming to first is D for defect. In organization, we usually in manufacturing industry we manufacture many products. And if the product is getting defect, means it affect our sales and overall profit of the organization. So for that we have to reduce the defect. So D stands for defects. And coming to another is overproduction. If a company is putting over capital on production, means they are going to face most of the cost of capital for the productions. So for that, to eliminate that wastage of money, we use the system which is called overproduction. We can manage effectively the cost of capital of the organization. And coming to W, waiting time. In coming to a production process, there is a number of processes in the production. So the waiting time for one would take another product, another process to take another long time, means it affect our overall production of the company, and it affect our sales also. And coming to N is a non-usage potential, because in companies there is a lot of machineries we have. Some of the machineries are very useful and highly potential. Some of these are not useful. There is old technology we have. We have to classify the machineries which we have in our organization, and we have to identify the unwanted machineries. We have to remove that in our organization. And coming to T for transport. If we are coming to see in a big organization like LGB, there is a large number of chain manufacturing companies. They are having many plants in many countries and many states. In the transportation, during the time we have a lot of difficulty we face. So for that we have to optimize, we have to reduce the transportation cost, and we have to optimize our motion of products from one unit to another unit. And coming to next is I, inventory. I stands for inventory, because we don't want to put over money on the inventory, because it lock our capital in one space. It affect our revenue growth also. So we have to use the money in inventories potentially.
Probably, yes.
And coming to next is M. M stands for motion. Because in each and every organization there are many employees are working. Because they are in that working hours 8 to 10 hours, means we have to use our work in a heavy effectively manner. So we have to plan what they are working, what is their schedule. We have to plan their motions, so we can able to work the human resource in effectively. And next coming to E, extra processing activities. Because the many companies are in manufacturing, they are doing an extra activities which is taking over time to do.
It's not relevant to the final product.
To that production level, so we have to cut down that activity also, sir.
So we have to identify and we have to cut. So really a very good explanation, and hope you are clear with what is this downtime, which is playing a very vital concept in the that is your Lean Sigma based things. Okay. So can you just summarize what we have discussed, and we can just close the session? Yes.
Firstly, thank you for the opportunity, and we have learned a lot about Lean Sigma. And firstly, I have explained about the history of Lean Sigma, that is when it was founded and which year it was founded and by which country. And secondly, Divya explained about the philosophy of Lean Sigma, and then Varadarajan explained about the 2 tools of Lean Sigma. And then we have solved the 8 types of waste and the abbreviation about the 8 types of waste, and I have explained the 8 type of abbreviation in detailed manner.
Yeah, really very thankful for your cooperation. Yes, I think we have delivered very good introduction related with the Lean Sigma concept, and I'm sure this particular video will be very helpful for the MBA graduates. So thank you very much. Thank you.
Thank you.
Okay, so as we had a very nice healthy discussion related to the case study, that is actually I just want to brief what we have discussed. See, actually we were discussing about there is just the Microsoft based case study, that is reducing the software bug density in DevOps pipelines through the Six Sigma. See, for example, at a scale as a massive, Microsoft software quality is not just a goal, it's a global necessity. Okay? At a scale as massive as Microsoft, software quality is not just a goal, it's a global necessity. In globally, we need the software quality, it's not just a goal. So, in order to tackle the bug density within their DevOps pipelines, Microsoft transitioned from the reactive debugging to the proactive Six Sigma approach. So, using the DMAIC roadmap, they defined the control, that is the critical to quality metrics, moving beyond the simple error counts to analyze the defects per million opportunities, that is DPMO, in the source code. So during the analyze phase, they utilize the Pareto charts and regression analysis to identify that a small percentage of the legacy code modules were responsible for the vast majority of system instabilities. So by implementing the improvement strategies like automated quality gates and AI-driven code reviews, so they effectively error-proof the deployment process before the code ever reached the production. So in the control phase, the real-time statistical process control, that is SPC charts, now monitor the pipeline, allowing the engineers to detect and resolve the special cause variations in the code performance instantaneously. So this integration of Six Sigma into the agile life cycle has allowed Microsoft to reduce the rework actually, and it has accelerated the release cycles, and it has ensured that the quality of the source remains the foundation of the modern cloud era. So this is what the discussion is all about. So thank you very much for your patient listening. If you really like this video, please give a thumbs up, and if you have any doubts, give a comment, and if you really feel that this particular video will be useful to someone, kindly share, and if you really like the videos which I post on the channel, please give a subscribe to this channel. Thank you.